So don't forget, in your Schoology, you have the access to the tutoring schedule. If you click on that, it's there. And then if you go to college algebra, you can see where my tutoring is. There is no tutoring tomorrow before school because there's campus-wide meetings, so none Wednesday morning. Normally, if there's not campus-wide meetings, then I have tutoring on Wednesday mornings. All of these other people who are not me have said they feel comfortable tutoring college algebra. So if you have questions in college algebra, you can always go try any of these people and see if they can help, because they all told me that they are comfortable tutoring college algebra. Okay. 7.0 is late, late, late. Max grade of 60. 7.1.1 factoring cubes is late, late, late. Max grade of 60. These grades are late, but you can still turn them in. I'll still give you credit because I haven't passed them back. I'm probably going to pass 7.2.2 back tomorrow. So then it'll move up here to the max grade of 70. So if you haven't turned in this 7.2.2 end behaviors that was due last Wednesday, tomorrow it's a week late. So I feel like that's been pretty lenient on you. Obviously, if you were out for like 4 or 5 days in a row, there would be some leniency on that. Okay. Because I'm not that mean. I'm kind of mean, but I'm not that mean. Okay. So again, we're going to be doing, and you also have access to your online textbook. So if something happens to your packet, you can always find it here. And so when you open it up, right now we are going to be looking at 7.3.1, which I believe starts on 117. 10, 11, 12, 13, 14, 15, 16. So we already did last Thursday and Friday. We did part 1, so we're going to start today with part 2, and we're just going to do the odds 15. I'm going to try to get through 27 today. 15 through 27 today, just the odds. And then if there's time, you can work on the assignment from Friday, or you can start working on the evens if you already finished the assignment from Friday. Okay? So the first thing that today's exercises are going to, and I just put them on this notebook paper to make it easier for me. If I have lines, it's easier. It says to use the rational zeros theorem to make a list of possible rational zeros for each of these polynomial functions. So again, I just took this. These questions are straight from these problems. Use the rational zeros theorem to make a list. So they're these problems. I just made them bigger gave myself room to work, which I definitely recommend scratch paper today. Okay. So when I'm using the rational zeros theorem, we talked about that on Friday. It's this one where we said the rational possibilities are P divided by Q, where P are the factors of that last term, and Q are the factors of the coefficient to the leading term. Okay, so you have to identify your leading term and your last term when the terms are put in order. Okay, so we're going to start with 15, 2x to the 4th plus 3x minus 7x squared minus 3x plus 3, which I already have typed out here. So the first thing we want to look at is, let me get something to write with, our last term. Because our last term, which we always think of as a sub 0, because it's going to be a sub 4, a sub 3, a sub 2, a sub 1. So this is a sub 0 because there's 0 x's attached to it. Okay. In this case, we don't care if it's positive or negative. We just want the absolute value of it. And it's 3. Because we use that to figure out P. P is going to be all the factors of 3. So 1 goes into everything. So 1's always going to be a factor. And then the only other thing you can divide 3 by is itself, 3, because it's a prime number. Okay. Then we look at a sub n. And a sub n is the leading coefficient. The leading coefficient. So since 4 is my biggest degree, the leading coefficient is 2. And that gives me my q values, which are the factors of 2. 1 goes in everything, so just 1. And then 2. Okay? So to find the possible rational zeros, so rational means there are values that can be expressed as fractions or whole numbers. Possible values, possible rational zeros. I'm just going to put zeros. We do P over Q. So if I look at P, I have 1 and 3 to choose from, and Q I have 1 and 2 to choose from. So I can do 1 over 1, which is just 1. I can do 1 over 2. And then I go to the 3. I can do 3 over 1, which is 3. And I can do 3 over 2. And then it's the positive and negative of each of those. So there's 8 possible solutions for us to just guess and check with. Yay, guessing and checking. But it narrowed it down from an infinite amount of numbers to just 8. And in this one, it just wanted to know what are the possible zeros so we don't have to actually go through and try them. This is my answer. What are the possible rational zeros? They're these 8 numbers. Questions on 15? Okay. I'm skipping 16. We're just going to look at the odds. And I'm going to go to 17. I'm going to do the exact same process. So the first thing I'm going to do is I'm going to figure out what is my a sub 0, my last term. And we don't care if it's positive or negative. We just need the absolute value of it. That's going to allow me to find my p-values. My p-values are the factors of 32. So 1 goes into 32, 2 goes into 32, 3 does not, 4 does, 5 does not, 6 does not, 7, 8 does, 9, 10, I think the next one's going to be 16, and then 32. Those are all my possible values of p. So then, to find q, we do a sub 4, which is our a sub n. In this case, it's a sub 4. Up here, it really should have been a sub 4 also, because this is a sub 0, a sub 1, a sub 2, a sub 3, a sub 4. So here we're a sub 4. If there's no number in front of the x to the 4th, then we know a sub 4 is 1, which is really nice. When you have a 1 in front of your leading term, that's great because it's going to really cut down on your possible solutions because the only thing that goes into 1 is 1. So it's just all of these numbers over 1, the positive and negative of each. So my possible zeros are 1 over 1, 2 over 1, 4 over 1, 8 over 1, 16 over 1, and 32 over 1. 1 over 1, 2 over 1, 4 over 1, 8 over 1, 16 over 1, and 32 over 1. And I spaced them out because I know it's the positive and negative of each one of those. So this is my answer. So there's 12 different possible solutions. Bless you. Since it's raised to the 4th power, I know there's only a maximum of 4 solutions, but here I have 12 that I could try. Okay. 4 of them might work, but remember some of the solutions could be complex or they could be irrational. Okay. 19, same exact process. What is my a sub 0 on 19? 7, good. So then my p is my factors of 7. It's a prime number, so it's just 1 and 7. My leading term is x to the 3rd power, so that means I've got a sub 3. I don't see a number in front of x to the third, so what is a sub 3? 1, which is really nice because that means q can only be 1. Possible zeros are going to be 1 over 1 and 7 over 1. Positive and negative of each. So there's only 4 things to try for this one, so that's kind of nice. If I was actually doing it, it would be nice that there's only 4 as opposed to 12. Questions on 19? Okay, let's look at 21. What is my a sub 0 on 21? Just 10. We don't need the negative. It doesn't hurt to put the negative, but. So P equals 1, 2, 5, and 10. I think that's everything that goes into 10. Nothing else divides evenly into 10. So then I need my a sub, this has a degree of 3, so my a sub 3. What's a sub 3? $17, the number in front, the leading coefficient. And we don't care if it's positive or negative, we're going to use the positive. That's going to help me decide my q values, which are going to be 1 and 17, because again, it's a prime number. Okay? I use those to find my possible zeros. So it's going to be 1 over 1, 1 over 17. 2 over 1, 2 over 17. 5 over 1, 5 over 17. 10 over 1, and 10 over 17. And it's the positive and negative of each of these. That's my answer. Okay, so in the next section, they're going to want me to actually find the real zeros. So I'm going to find the possible zeros if I need to. If I can't factor, I'm going to find the possible zeros, and then you just fun times, guess and check until you find ones that work. Okay, so when it says real zeros, that means zeros that are not complex. They should have no i's in them. Okay, so no negatives and square roots. This one here, x to the fourth plus 2x squared minus 15. This one is kind of deceptive. Let's see if I can zoom in just a little bit. It's kind of deceptive because on this one, we're used to factoring x squared and x, but you can also use the x method when you have a 4 and a 2 and a 0. And it works exactly the same. Okay, so if I wanted to use the x method on this one, remember, the first thing you do for the top numbers, you multiply a times c, so that's negative 15. And then your b, put plus 2. We want multiples of negative 15 that add to 2. So my multiples of negative 15 are going to be 1 times 15, 3 times 5, and that's going to be it. Since I want a negative 15, I know one of these has to be negative, so I'll really be subtracting to get my plus 2. Which am I going to subtract to get my plus 2? The 3, right? So if I do minus 3 and plus 5, I get a positive 2. If I multiply them, I get my negative 15. So over here, I go over 1, because it came from here, this 1 right there, -3, and 5. So this f of x, we're really trying to find the 0, so that's really 0, equals, normally we would use the denominator and say 1x minus 3. But since we have x to the 4th, it's really 1x squared minus 3. And here it's 1x squared plus 5. So that's an important pattern to keep in mind anytime you have a to the 4th power. If it factors, it's way easier than using the guess and check method because sometimes that takes a while. Okay, so since both of these we want them to equal 0 when they multiply, that means one of these two sides has to equal 0. Okay, so x squared minus 3 equals 0, and or x squared plus 5 equals 0. And then this we just solve it, right? We start by, on this one, we're going to add 3 to both sides so that my 3's cancel out, which leaves me with x squared equals 3. How do you unsquare something? Square root. Remember when you square root, it really does the plus and the negative version. So x is going to equal positive and negative square root of 3, which is a real number, right? It's not imaginary. There's no negative in my square root. So that's a good answer. And then we do this side also. So I do the same process. I'm going to get x squared by itself. I'm going to subtract 5 on both sides. And that's going to give me x squared equals a -5, which when I square root, what happens when I take the square root of a negative? Plus or minus, what happens with the negative in the square root? No. How do you take a negative out of a square root? It tells you when you put it in a calculator, the square root of -5, it's going to give you an error and tell you non-real calculation because it comes out as what letter? An I, right? So that's really I square roots of 5. But we want the real zeros, so we don't care about this one. My answer is just this side. Okay, so don't forget that. You have to remember all the stuff from the previous units. So you have to remember these fun, complex numbers as well. Okay? All right, let's look at number 25. Number 25, I have an x cubed minus 7x squared plus x minus 7. So that one is not a square or a to the 4th that's factorable in a way that we know how. There's nothing I can take out of all of those. So I'm going to have to use the guess and check method where I look at my P over Q so I kind of know what are my options to guess and check, right? So my A sub n, or A sub 0, is my last number 7. So that means my P values are just 1 and 7. My A sub 3 is a 1. So my Q is 1, which is really nice because that means my possible values, my things to try, my possible zeros, are 1 over 1 and 7 over 1. So that means there's only 4 things to try. So remember, to try them, you do synthetic division, and you want a remainder of 0. Okay? Check to make sure that you have 3, 2, 1, 0. So we're good. 3, 2, 1, 0. So I can do synthetic division. So I'm going to try, let's start with 1. I have 1x to the 3rd minus 7x squared plus 1x minus 7. The 1 comes down. So that's a 1. 1 times 1 is 1 plus -7, -6. 1 times -6 is -6. -6 plus 1 is -5. -5 times 1 is, and that's not going to give me 0, right? That gives me -12. So 1 doesn't work. So now we can try -1. -1. 1, -7, 1, -7. The 1 comes down. -1 times 1, -1. -7 minus 1, -1 times -8, 8 plus 1. So that's not going to work because that's going to be -9, so that's -16. That doesn't work. We only have 2 more that we could try. So let's try 7. We have 1, -7, 1, -7. The 1 comes down. 7 times 1, 7 plus a -7, 7 times 0, 1 plus 0, 7 times 1. Yay! Look, we got it. Okay, so that means x equals 7 is a solution. That might not be all of the solutions, though. There might be more, so we need to check. Okay, so now I have this new equation. Remember, if this started with x to the third, then after I divide by the 7, I have 1x squared plus 0x's plus 1. So now I have this that I'm going to try to factor. I have 1x squared plus 0x plus 1. So we can see if it matches one of the formulas that we have up around the room, or we can try to use the x method because it's a squared, right? It's a quadratic. Or I could use the quadratic formula. Do you want to try one of the formulas around the room? Do you want to try the x method? Do you want to try the quadratic formula? What do you want to do? Doesn't matter to me. We could factor by grouping. Somebody pick, or I'm going to pick the most difficult. If you let me choose, I'm always going to pick the most difficult. The x method. All right, so let's try the x method. Remember, for the x method, we want to multiply to a times c. So 1 times 1, so I want to multiply to positive 1. And I want to add to the middle term, so I want to add to 0. And this goes over 1, and this goes over 1. So my multiples of positive 1 are just 1 times 1. Can I get a 0 with that? No, because if I make both of these negative, that's not going to work, right? But if I don't think of this as a 0x, if I just think of this as just x squared plus 1 equals 0, can't I just solve that because there's not an x value? What do I do to solve this? I can't square it. I have x squared plus 1 equals 0. Subtract 1 on both sides. Do y'all see how I got rid of that 0x, right? Because 0x is just 0. So then I have x squared equals a -1. Oh, what's going to happen there? Square root. And so notice I'm square rooting a negative. So what do I immediately know? It's going to be what? It's going to be complex. It's going to have an I, so I don't care what it is, because these questions just said to find the real roots. So my answer then my solution is just x equals 7 because my other solutions are complex. The other two solutions are both going to be complex. It'll be positive and negative I square roots of 1. Questions on 25? All right. This, I believe, is the last one we're going to look at today. Yeah, because we're going to start 29 tomorrow. This one's a doozy. Get a fresh sheet of paper. All right. So 36x to the 4th minus 12x cubed minus 11x squared plus 2x plus 1. There's not something that they all have in common, so I can't just factor something out because they don't all have something in common. So I'm going to have to guess and check. Yay. My a sub 0 is what? 1. So that's nice. My p is just 1. My a sub 0, 1, 2, 3, 4 is 36. So that does have some factors. My q is going to be 1, 2, 3, 4, 6. 6 times 6 makes the 36. 4 times 9 makes 36. 3 times 12 and 2 times 18. Oops, 18. What did I just do? I don't know. I rotated. I thought that was an undo. 18 and 32. So my possible solutions, my possible zeros are 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 6, 1 over 9, 1 over 12, 1 over 18, and 1 over 32. And it's the positive and negative of each of those. All right, let's start testing. Good times. Let's try the first one. Let's try 1. And I have 4, 3, 2, 1. So I've got all of me. I don't have to put any zeros in. They're all there. So I've got 36, 12, negative 12, negative 11, 2, and 1. All right. So the 36 comes straight down. 36 times 1 is 36. I take away 12, so that's 24, times 1. I take away 11, so that's 13, times 1. That's 15 times 1. That doesn't work. 1 doesn't work. Let's try negative 1. Negative 1. 36, negative 12, negative 11, 2, and 1. 36. 36 times negative 1. The two negatives added together are negative 48. Times negative 1 is a positive 48. Take away 11 is 37. Negative 37. Take away or add 2 to a negative. Negative 35. 35. Nope. That has a remainder. So that doesn't work. Let's keep on going. So neither one of my ones worked. Let's try, you want to try negative or positive 1? Half. Nobody said. Let's go positive first. Try 1/2. Now remember, when you synthetically divide by a fraction, when you get your answer, if we have a remainder of 0, or whether or not we do, you have to divide all of those that aren't zeros by the denominator, by 2. Okay? So I'll show you what I mean if this one works. If it doesn't work, whichever one does work, we will have to do that too. 36, -12, -11, 2, and 1. 36 comes down. What's half of 36? Half of 36? Oh, this is 36, not 18. Sorry. 18. 18 minus 12? 6. Half of 6? -11 plus 3 is -8. Half of 8? 4. 4 times 2, 4 plus 2? Which one? Oh, this one? Oh, yeah, because it's a -8. 2 plus a -4? -2. Half of -2 is negative. Oh, hallelujah. We found our 0. But remember, we have to take each one of these here and divide it by the denominator here. You don't divide the remainder, although in this case it wouldn't matter. But if you had a remainder, you don't divide the remainder. Okay? And then don't forget, this one's going to be x. We started with x to the 4th, so this is going to be x cubed plus x squared minus x to the 0. So my new equation is, here's my new equation. My new equation is, I can't see, 36 divided by 2x cubed, so that is 18x cubed, plus 6 divided by 2 is 3x squared, minus 8 divided by 2 is 4x, minus 2 over 2 is 1. So now I want to find the zeros that go into this one. So I do the same process because this is so fun. All right, so a sub 0 is 1. So that means P can only be 1. A sub 3 is 18. So that means Q can be 1, 2, 3, 6, and 18. So my possible zeros P over Q. So 1 over 1, 1 over 2, 1 over 3, 1 over 6, 1 over 18. Now, here's kind of the neat thing. Because 1 and -1 didn't work in the original one, guess what that means? 1 and -1 are not going to work here either. If they didn't work in the first one, they're not going to work in the second one. Okay? All right. So we have 1/2, -1/2, 1/3, -1/3, 1/6, -1/6, 1/8, -1/8. What do we want to try? Oh, yeah, it is divisible by 9 also. And positive and negative, 1/9. Good catch. All right, so positive and -1 can't work because it didn't work in the original. What do you want to try next? What color 1/2, and we already know positive 1/2 works up here. So if it works here, that just means it has a multiplicity of 2. So let's try negative 1/2, okay? Because I already know positive 1/2 for sure is already a solution. So if I find it out again, I haven't really solved anything, right? Does that make sense? So I'm going to try negative 1/2. So negative 1/2. My coefficient of change now, they're 18, 3, negative 4, and negative 1. The 18 comes down. Negative 1/2 of 18 is a negative 9. 3 plus a negative 9 is negative 6. Negative 1/2 of negative 6. Negative times negative is positive. Half of 6 is 3. Negative 4 plus 3 is negative 1. So that's not going to work because I need to get a 1 here, right? I'm going to end up with a positive 1/2, which is going to leave me with a negative 1/2. So that doesn't work. You want to go to 1/3 next on the list? Why not? 1/3. 18, 3, negative 4, negative 1. 18 comes down. 1/3 of 18. 6 plus 3. 1/3 of 9. Negative 4 plus 3. 1/3 of negative 1 is negative 1/3, so that's going to be negative 4/3. So that's not going to work. You want to try negative 1/3? Why not? Try negative 1/3. All right, so negative 1/3. We have 18, 3, negative 4, negative 1. 18 comes down. We already know 1/3 of 18 is 6, and it's negative, so we change it to negative. Negative 6 plus 3. Negative 6 plus 3. Negative 3. 1/3 of negative 3. Negative 1. Positive 1. Yeah, because it's a negative times negative. Negative 4 plus 1. Negative 3. Negative times negative is positive. 1/3 of 3 is... Oh, hallelujah. So remember, because we did negative 1/3, we have to then divide each of these by 3. And this is x to the third, so that means this starts with x squared, x, and 0. So my new equation is (18 divided by 3 is 6, x squared, minus 3 over 3 is 1, x, minus 3 over 3 is 1. So this, I can try factoring it, or I can use the quadratic formula. This one, it's x squared, so I could try to do the x method. 6 times negative 1 is negative 6, and I want a negative 1 down here. Right? Did I do that right? Negative 6, negative 1. 1 times 6 and 2 times 3. Can I get a negative here? Yeah, which one? 2 and 3. Which one has to be negative if I want to get a negative 1? Negative 3. So I'm going to have, this is going to be over 6 and this is going to be over 6. That's different from what we normally do. It's over 6 because there's a 6 here, right? So I'm going to do 2 over 6 and negative 3 over 6. That reduces to 1/3. This reduces to negative 1/2. So that means this one is 3x plus 1. And this one is 2x minus 1. So that means either the 3x plus 1 equals 0 and or the 2x minus 1 equals 0. On the left-hand side, we subtract 1. (3x) equals negative 1. Divide both sides by 3. X equals negative 1/3. On the other side, we add 1. So 2x equals 1. And then we divide by 2. So x equals 1/2. All right, so watch what happens when I zoom out. And I look at the whole problem. Whew, a lot going on. All right, so the things that worked are my solutions. My solutions are x equals 1/2 worked. Negative 1/3 worked. Negative 1/3 worked. It worked twice. So what that tells me is it's a multiplicity of 2. So that means it touches the axis right there in a U, either facing upwards or facing downwards. I'd have to do more to figure that out. And then 1/2 happens twice. So that means it also touches there twice. Does that make sense? So that means it makes a parabola shape at both 1/2 and at negative. That's a negative 1/3. So my 4 solutions are 1/2, 1/2, negative 1/3, negative 1/3, but 2 of them are the same, right? So you only are 2 solutions. Okay, so all of that fun stuff is all number 27. We will continue tomorrow with the rest of the odds in this section. If you've already finished the homework that was due today, then your homework tonight is to try to do the odds up through 27. And then we'll pick up finding all the zeros. So that means also the complex ones for 29 through 40.